Good morning and welcome to the 26th episode of Ahargana. We are getting close to the end of the Ahargana series and I am going back to where I started. I am at a spot which I count as my most favoritist viewpoint in the entire world, and this is in the Kaveri Wildlife Sanctuary. On top of a small hill, and I can see the Kaveri river winding around down below before it goes on to Mekedatu and then continues beyond and crosses the border into Tamil Nadu. Wonderful spot to be in. This is where I started episode 1 of Ahargana, though episode 1 I took down at water level, and then subsequently I made one more episode with pretty much exactly the same view that you see behind me. And that's why I say I am back to where I started, since I am winding down Ahargana. It's early in the morning, the sun is in this side, you can see the golden light of the sun on my face. Very gentle breeze blowing. It's a stiff climb to get to this spot, and it's harder for me now than it was 2 years back. 2 years back it was much easier. But here I am, and also, as always, it's nice to be here. A very gentle breeze and just a few birds chirping around. And I can hear the water down below. Even though there is not much of a flow, it's a rocky river bed down there. There is that murmur of the river. I don't know if the microphone catches that. Wonderful spot, wonderful to be back where I started. But we are not here to discuss nature, not even on this scale. We are here to discuss nature on a much grander scale of the sun and the moon and the stars, specifically the sun. So we are in Savana Ahoratra, and we had seen exactly what is the definition of a sunrise in the last tutorial, and now in this episode we will look at a Savana Ahoratra, sunrise back to, and onwards to the next sunrise, sunrise, sunset, and back again to the next sunrise. I will show that to you in Stellarium in this episode, but that's not so much the point. The critical point here is again the duration of a Savana Ahoratra. It's always the duration. So we have seen in Nakshatra Ahoratra that the duration is fixed and it is 4 minutes short of 24 hours. Savana Ahoratra, I will show you, is not fixed, and it is not 24 hours, and that is the crux of this episode. We all believe that a solar day is 24 hours, but that 24 hours is only an average. The actual duration of a solar day fluctuates around this average by less than a minute. 5 seconds, 10 seconds, 15 seconds, 30 seconds, 40 seconds. It could be less than 24 hours or it could be more than 24 hours. So it fluctuates around that 24-hour point. And the 24 hours is actually a real average over 365 days. The average solar day duration across an entire Saura Varsha will be 24 hours. Whereas every individual day will slightly vary by less than a minute, around 24 hours. Now you may say it's less than a minute, around 24 hours, how does it matter? But it is cumulative, it adds up, and that is why you find that in the modern clock, the time of sunrise and sunset varies across a year. In summer, sunrise is much earlier, and in winter, sunrise is much later, and converse for sunset. And that variation happens because this duration keeps changing. So I will illustrate that to you using Stellarium, and also I will show you some graphs and charts to show the duration of a Savana Ahoratra over an entire Saura Varsha period, over an entire 365 day period, so that you understand the variation and you understand that it is not fixed at 24 hours. The 24 hours is only an average. And I am doing all this, I am showing you that Nakshatra Ahoratra is fixed, less than 24 hours before minutes, Savana Ahoratra is variable around 24 hours. I am doing all this because this has an impact on designing a Hindu clock. The variation in duration around 24 hours and the fact that Surya Siddhanta says Savana Ahoratra starts with sunrise. In fact, that is all the Surya Siddhanta says about Savana Ahoratra. Savana Ahoratra starts with sunrise and lets you figure out all the rest. And what is the impact on the Hindu clock, that I will talk to you about in the next and final episode of Ahargana. Now, as to why this duration varies, it is not fixed, it is easy to guess, because you know that this sunrise sunset happens because the earth is spinning on its axis, and that is steady, that is not varying. Yeah, there is no variation across summer and winter, that is a steady spinning across. But the sun is also moving. So, you have two things, one is this is moving and this is moving, two movements happening, and it is the combination of those two movements which creates this variation. So, we will proceed to the animation now. I am going to roll the animation, take a look. Okay, let us get started. In the last tutorial, we had taken a look at exactly what is the definition of sunrise. Many people take the definition as the tip of the sun peeps over the horizon, that is sunrise, but astronomically I am more comfortable with taking a definition where half the disk of the sun is above the horizon, because at that time the altitude of the sun is 0 degrees, and that is easy for me to work with. In this episode, we will take a look at an entire Savana Ahoratra. Now, the Surya Siddhanta says very little about Savana Ahoratra. It simply says that a Savana Ahoratra begins with sunrise. That is all. It does not say anything more. But what are the implications of this statement that a Savana Ahoratra begins with sunrise? That is what we are going to investigate in this and the subsequent episodes. So, I am back in Stellarium, and I picked a specific date of March of this year, 24th March 2024, 6:22:09 seconds, 6:22 in the morning. I am in Bangalore facing north, and this is east, this is west, and the horizon is a little bit curved because the curvature comes because of the distortion when mapping from 3-dimensional space into a 2-dimensional screen, and I have zoomed out quite a lot to fit everything into the screen, east, west, north, everything into the screen. Now, you can approximately make out the sun is somewhere here because it is looking like dawn, and I am going to show you that indeed is dawn. Take a look. I am zooming in on the sun, and there you go. You see that half the disk of the sun is above the horizon, and the altitude is 0 degrees. 0.0011 degrees. I am unable to bring this exactly to 0 degrees because Stellarium does not allow me to deal with fractional seconds. If I take it to 8 seconds, it goes to minus 0.0023 degrees. So, I prefer to stay with what is closer to 0, which is 0.0011 degrees. And the time is 6:22:09. I am showing it here also, sunrise on March 24th, 6:22:09. Now, I am going to run the animation, and you will see a Savana Ahoratra in progress. So, Stellarium is animating the movement of the sun, the rising of the sun. Now, it is approaching the zenith, and it crosses the zenith. It is now beginning to set. Sun is going down. And there is sunset. Dark skies, and it looks like a night of the full moon, Paurnami, Purnima, or at least almost close, maybe Chaturdashi of a Shukla Paksha. But that's not the point. Now the sun is coming back to the next sunrise. That means the Savana Ahoratra has ended and the next Savana Ahoratra is about to start. So the date has now changed to 2024 March 25th at 6:21:29. I'm showing the date here also. The previous sunrise was at 6:22:09. This sunrise is at 6:21:29. So let's just confirm that this is indeed sunrise. So once again I am zooming in. And once again half the disk of the sun is above the horizon. Last time it was 0.0011. Now it is 0.0006. Pretty close to where it started. I can't get the exact precision I want, but this is okay for our purposes. But the point is that there is a difference in the sunrise time. It's not the exact. See, if the duration of a Savana Ahoratra is 24 hours, then the next sunrise should have been at 06:22:09. But no, the next sunrise is at 06:21:29. That means the duration of this Savana Ahoratra, which you saw just now, is 40 seconds less than 24 hours. 23 hours, 59 minutes, 20 seconds. So it's 40 seconds less than 24 hours. Now, we are all used to believing that a solar day is 24 hours because that's what our watches tell us, that's what our clocks tell us. But the reality is different. You can see that in this case, on March 24th, 2024, the day was 40 seconds less than 24 hours. Now, you may say it's only 40 seconds, it's no big deal, but I'll show you a little bit later that this is cumulative. It's 40 seconds, another 40 seconds, another 40 seconds, and soon you are running into minutes day after day after day. But the point is, it's not exactly 24 hours, it's less than 24 hours. So can I take it that every single day of the year, the Savana Ahoratra is 40 seconds less than 24 hours? No. I'll show you another example, this time from December 9th, 2024. Sunrise is at 6:31:43. So once again, let's check if half the disk of the sun is above the horizon. Yes, there it is. Half of it is above the horizon. Is it 0 degrees? It is minus 0.0015 degrees. Can I get it closer to 0? I go 1 second forward. It went to plus 0.0017 degrees. I'm not able to get it exactly to 0. So let me stay with where it is closer to 0. This one. So 6:31:43 is the time of sunrise. And let's take a look at the duration of this Savana Ahoratra. So let me run the animation. The sun is rising, heading towards the zenith. You can see that there are some variations in this animation. Last time the sun did not come up to the edge of the screen. Now this time it has come up to the edge of the screen. But those variations we are not interested in right now. I'm only interested in the duration of a Savana Ahoratra. Now sun has set, dark skies, a lot of things are happening. You can see Saturn, you can see the moon, you can see Jupiter and Mars. Everything is visible on the December 10th night in the sky. And the next sunrise has come. And we came back to minus 0.0013 degrees, and the time once again is not the same as the previous sunrise. The next sunrise time is different, 06:32:16. Let's check once again if it's really indeed half the disk of the sun is above the horizon. Yes, it is. And what is the duration of this Savana Ahoratra? Now you see, this Savana Ahoratra is greater than 24 hours by 33 seconds. The previous example I showed you was less than 24 hours by 40 seconds. Now this is greater than 24 hours by 33 seconds. So there seems to be significant variation in the duration of a Savana Ahoratra depending on which month you are in. Sometimes it is less than 24 hours, sometimes it's greater than 24 hours. So what's really going on here? We have always been told a day is 24 hours. We believe it is like fixed 24 hours. But you should have guessed that a day cannot be exactly 24 hours because you do know that the time of sunrise varies. Summer sun rises early, winter sun rises late. We all know this. That cannot happen if every day was exactly 24 hours. Then the sun will rise at exactly the same time, day after day after day after day. And that is not what's happening. So this 24 hours is only an average duration of Savana Ahoratra across an entire year of 365 days. And clockmakers have adopted that average because they need a constant value to work with, because clocks run like clockwork, they keep on ticking at the same speed. Clocks don't vary, suddenly go faster, go slower. Clocks are very regular. So the 24 hours is only an average across the entire solar year. So I showed you just an example of 2 days in a year. Now I'm going to show you all 365 days of 2024, but I cannot show it to you using Stellarium. I'll have to switch over to a graph, a chart, and show you the duration of Savana Ahoratra and how it varies over the entire 365 days of this year, 2024. To analyze the duration of Savana Ahoratras across an entire year, I now switched over to a graph. The data for this graph I obtained not from Stellarium but from something called NASA JPL Horizons software. That software allows me to get the ephemeris of any solar system object, including the sun. Ephemeris is nothing but a time series of the position of that object. So I obtained the ephemeris of the sun, and using that I obtained the time of sunrise. That is when the sun's altitude, elevation becomes 0 degrees. And then the rest is computations, subtraction to determine the duration of a Savana Ahoratra. So in this graph, on the x-axis I am plotting time, January, February, March, April, May up to December. And there is a bar for every date in that month. So this is January 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th. So there is one bar for every month. The length of the bar indicates the duration of a Savana Ahoratra in hours. Hours, minutes, seconds, but I converted it into a fractional hours. So if you take here 1st January 2024, the duration of a Savana Ahoratra was 24 hours 0 minutes 22.5 seconds. That means it deviated from 24 hours on the positive side by 22.5 seconds. The deviation is how much different it is from 24 hours. But if you go to the next date, 2nd January, the duration is 24 hours 0 minutes 22 seconds. Whereas 1st January was 22.5 seconds. That is the degree of precision which JPL ephemeris gives me. NASA JPL Horizons ephemeris gives me half a second precision. So you can see that the duration is gradually decreasing starting from January 1st. It started 22.5 seconds more than 24 hours. And then it kept on decreasing until somewhere here it came to exactly 24 hours, 23rd January. The duration of the day was exactly 24 hours. Then it continued reducing, so it's now gone below 24 hours. So it is 23 hours, 51 minutes, that is 9 seconds less than 24 hours. Here it is 23 hours, 38 seconds, that is 22 seconds less than 24 hours, and so on until it bottomed out somewhere around March 24th. And this I showed you in Stellarium. So March 24th, the duration is 23 hours, 0 minutes, 18.5 seconds. In Stellarium, I showed you 23 hours, 0 minutes, 20 seconds. There is a difference apparently in the way the sun's rays refraction effect is calculated between Stellarium and JPL horizons. So that brings about a little bit of a time difference. But what we are looking at here is a pattern. And the fact that the duration of a Savana Ahoratra is not 24 hours day after day after day. Sometimes it is more than 24 hours, sometimes it is less than 24 hours. Here again, in this whole segment starting from somewhere around end of May onwards, it's always greater than 24 hours. But between end of January to end of May, duration of a day is less than 24 hours. And each day varies by a few seconds. So here it is 41.5 seconds less than 24 hours. Here it is 33.5 seconds more than 24 hours. But it is still in seconds. Day after day, the variation is in seconds. 10 seconds, 5 seconds, 15 seconds, 20 seconds, 30 seconds, 40 seconds. But the fact remains, it is not 24 hours. And another interesting fact is the average duration over the entire year, 365 days, is exactly 24 hours. This is a computed value, 24.00000 hours, exactly 24 hours. So the 24 hours we are familiar with is only an average. The real duration day after day varies from this average by a few seconds. Maybe 5 seconds, maybe 30 seconds, maybe 40 seconds, but it varies. Now you may ask, okay, understood, it's not 24 hours every day, a little bit more, a little bit less, but it's only a few seconds, how does it matter? Right? For example, if I look at the time of sunrise on any given day, I am told sunrise is at 6:33 today. Nobody tells me 6:33 and 20 seconds. Nobody tells me those seconds. We don't even care about the seconds. Why are you emphasizing the seconds? That's because these seconds are cumulative, these variations. And the cumulative effect is that we see throughout the year that the time of sunrise varies. I will show you that in another graph, sunrise graph. So the x-axis is still the same, January, February, March. Instead of bars, I have just put dots now. So this dot is January 1st and it says 6:45, 20.5 am. This is the time of sunrise on 1st January in Bangalore, according to JPL Horizons Ephemeris. Most websites will tell you 6:45 am, but I can get to the precision of half a second. So I'm going to 6:45 am and 20.5 seconds was the time of sunrise. And this time of sunrise, you know, it varies day after day after day. It's a very well-known fact. If every day was 24 hours duration, why will the time of sunrise vary? Sun will rise at the same time day after day after day. So that itself should tell you that something is not right when you say 24 hours is the duration of a day. It is varying. So sunrise becomes later and later and later, and somewhere around 24th, 25th Jan, it becomes as late as 6:49, 6:50, almost 10 minutes to 7, that late sun rises. But after that, it starts rising earlier. So by the time you come to summer, in May, sunrise is at 5:53, 16.5 seconds, 5:53, 12.5 seconds, etc. Then it comes to 6 a.m. On 8th July, it comes to 6, and then again it starts becoming later and later, stabilizes, and finally by December, sun is again rising at 6:45 a.m. So this variation in the time of sunrise can happen only if the duration of Savana Ahoratra changes day to day by a few seconds. Those few seconds matter because there's a huge difference, right, between sun rising at 10 minutes to 7 to sun rising at 10 minutes to 6, 7 minutes to 6 here. Almost an hour difference. So those few seconds every day added up to almost an hour difference in sunrise across 5-6 months because it's cumulative. So the key takeaway in this video is that 24 hours, which we are familiar with, that is not the exact duration of a day, that's only an average across the entire year. And the duration on every day varies by a few seconds, day to day to day. Now there is another implication of this, and that pertains to clock making and clock design. But that is for the next episode. So I will close this episode here. Thank you very much for watching. So that brings us to the end of the penultimate episode of Ahargana. So you understand now that a Savana Ahoratra is not exactly 24 hours, it varies around 24 hours. And you also know Surya Siddhanta says that Savana Ahoratra starts with sunrise. We have already seen that Nakshatra Ahoratra is fixed, but that is not 24 hours, it's 4 minutes short of 24 hours, and that is used to define Nadi, Vinadi and Prana. So in the next episode we will take that Nadi, Vinadi and Prana definition coming from Nakshatra Ahoratra, apply it on top of Savana Ahoratra, and also in addition fix the start of a Savana Ahoratra at sunrise. And you will see when we do that, that it necessarily leads to a discontinuity and the beginning of every Savana Ahoratra. It's not difficult to understand this, but I will show you, I will illustrate to you in the next episode what I mean by discontinuity. What it essentially means is in the modern clock we keep going round and round and round regularly, continuously, day after day after day, whereas in the Hindu clock that regularity will be broken every day, and the sun and the clock will be reset to 0 Nadi, 0 Vinadi, 0 Prana at every sunrise. It will be moving and then boom, it has to jump back, then it will be moving and then it has to jump back at every sunrise, because the Surya Siddhanta says that a Savana Ahoratra starts with sunrise. There is no option of saying tomorrow the sun will rise at a different Nadi, Vinadi and Prana. No, sun has to rise at 0 Nadi, 0 Vinadi, 0 Prana every day. Think about it. And as you think about it, I will bring this episode to a closure. Thank you very much for watching this episode. Thank you very much for staying with Ahargana for such a long time. And please, please, please forward the link of the channel to all your friends and all your contacts, so that more and more Hindus come to understand and appreciate the astronomical basis of our Hindu calendar. And I am hoping that this Ahargana series and what I am doing with this series triggers thoughts in other people to take this thread forward in various other directions. For example, the Surya Siddhanta talks a lot about how to determine eclipses, how to determine conjunctions of planets, oppositions of planets, etc. That involves a lot of numerical methods, mathematics. In fact, the Surya Siddhanta has its own definition of a sign table. It's not exactly a sign, it's called, I think, worst sign or R sign or something, which I haven't fully understood yet. I haven't studied that section at all. So there is a lot more to be studied, and I am hoping that one of you who are watching this series will pick up this thread and run with it and take it in different directions. In fact, there is so much of Hindu astronomy which has not been studied at all, which should be studied according to me, because it's our tradition. So with that, I bring this episode to a closure, and until I see you again in the next and final episode, take care and bye-bye.